All right. Before we get started, do a quick introduction. My name is Kyle O'Brien. I lead corporate development at Zama. Super excited to be here and really thrilled that all of you are able to I almost said join the Zama CoFHE Shop. This activation is going on all week. So if you're in town for DevConnect and you're thirsty for coffee and FHE, this is the place to be. Today I have the privilege of interviewing Juan Benet, the founder of Protocol Labs and a number of other projects that we'll get into momentarily. Thanks, Juan, for joining. Super excited to have you here. I think you're a man that needs no introduction, really. But perhaps you can tell us a little bit about how you first got into contact with blockchain and distributed systems.
Yeah, and thanks for having me. Excited to be here chatting and having coffee. It's like really, or not coffee. I'm having water, but you're having coffee. So I first got into distributed systems. I first got interested in distributed systems probably in early 2000s, thanks to peer-to-peer networks. So things like BitTorrent and Kazaa, and then Skype. So Skype for me was the really cool one where I saw this go from kind of like a tech that was kind of counterculture and underground into providing a major service at scale for, I don't know, tens of millions, if not hundreds of millions of people globally. And they were able to build, a telephony network, bringing together people globally, massively dropping the cost of conversations. And for me, like, I don't know, I was like in high school, no, less than high school, like middle school probably at the time. It helped my family connect with people globally. And it was this demonstration of the power of the internet to completely upend how current structures had worked. And then when I started computer science formally in college, when I started distributed systems and networks formally in college, like that was the much deeper introduction into the subject. And spent a lot of time studying file systems and distributed file systems. Did a bunch of networks research, so wireless networking and things like that. And kind of what got me into the field was this idea of like, whoa, the internet is a super powerful thing. There's people all over the world have computers. They're being brought together by these programs. I used to play a lot of games. And I kind of grew up online. And so I was always curious as to how the internet was built, how were all these computers talking to each other. It just seemed like a super interesting and exciting thing to be a part of. And once you start studying formally, you realize that all of it is just like a collection of little programs that random people came up with. And it's super malleable. Like you can imagine some new superpower that you can want to give the world. And you can just, one person or a small group of people can make that into some program and then distribute it to the world. And now the world has like an additional superpower. And, the more you like look under the layers of how the computing infrastructure has been built, it's just like, this alphabet soup of protocols, HTTP and IP and TCP and SMTP and like, ton of like IETF protocols that are just started with, discussions on paper, descriptions of the protocol, and then people write different implementations, and then they agree to run them, and then it all just sort of works. And part of it is like, it's amazing that it works. Like it's just kind of all cobbled together. But on the flip side, it just shows the power of emergent systems and open networks and well-defined APIs and interfaces and so on. And that's kind of like what kind of really got me into it. Probably the other thing that helped was that I was considering going into AI, but at the time it was like the last legs of the AI winter. And I remember having a chat with Andrew Ng, who at the time was like leading the AI lab at Stanford. And he was like, oh, AGI is like never going to work. Like it'll be centuries. And it just like was like, okay, well, like this field is screwed. I'm going to go to distributed systems. So
AI is dead. Long live AI.
yeah, it was really funny because like literally the next year was when the deep learning results started arriving. And that was like another proof of like, don't trust the experts often, like really figure it out for yourself.
Could have been a very different world if you had gone into the AI space instead of
yeah, like I dabbled in it, but yeah, it was just kind of things weren't working as well yet, and I don't know, distributed systems and crypto like just kind of took off really fast.
Yeah. Okay, so you made contact, through the early days, and then you ended up developing IPFS, Filecoin, later on Protocol Labs. Now you've funded a ton of research, you've funded a ton of companies that are working in the space, and a recurring theme that comes up that you've talked about before is the decentralized computation triangle is the way you describe it, the trade-offs between privacy, verifiability, and performance. Can you tell us a little bit more about that and how that factors into your philosophy around building companies and
Yeah,
computing?
yeah, totally. So in distributed systems, there's often, and in computing in general, there's often a landscape where that has a set of trade-offs that you have to reason about. And so, maybe the most famous one is the CAP theorem, which is kind of like consistency, availability, and partition tolerance. These three things are really hard to have at the same time. There's like good formal proofs that show you can only have two at a time. But most systems that have success have, maybe pick two for strong guarantees and like have a lot of tricks to try and achieve the third item. But it really just tells you that there's these tensions between properties, and when you lean too hard in one direction, you have to give up something else. And in when we started with, or I started with information addressing and distribution with IPFS, because I was kind of solving a concrete set of problems around data set package management and trying to build like a better, faster way for people to distribute data sets. And that led me to kind of recombine a bunch of ideas that I had been thinking about for many years of like, hey, what if you could have like the BitTorrent style distributed network, but with the version control magic of the Git protocol? And what if you could then put this in a distributed file system and then enable all computers to join it? And so you can like save and open files to it like you would in your computer. And then wait, hold on. What if you could like represent an entire website in this and expose it to the browser? And like, whoa, that means like you can have peer-to-peer websites. You can like, drag and drop a website kind of like you would a file on BitTorrent, and then make anyone be able to serve the web page and serve the thing. And that seemed like a super cool idea. And so I kind of just went in that direction. But all the while I was thinking about how can you both incentivize the distribution of this data? How can you couple it with computation in different ways? The entire history of computer science is just how you arrange data and programs are represented as data. So like, it's really about how do you arrange and address data and how you decide what data is executable to then run on top of the other data, and you produce more data and you produce more programs. And it's just like everything in the last 80 years has been different structures and arrangements for how to teach matter to like run these computations on top of our digital data. And so lots of protocols and systems just give you different trade-offs about how to do that. How do you address the data? How do you move the data? How do you run programs? Who has power of running those programs? How do you deal with like access controls? Who has the visibility into looking into some of that data? Is this data public? Is it data private? Is it private for a group? And so all of these like little details are just kind of different pieces of the same fundamental like code and data component. And so as I was building IPFS and Falcon and so on, I was always very keenly aware and thinking about how do you blend different types of computation into that landscape. And as you think about the centralized storage is kind of a lot easier than decentralized computation in a bunch of ways. Because when you try to do decentralized computation, you have this serious set of trade-offs that I pulled into this triangle, where if you want really high performance, then you ideally have like a trusted environment where you don't have any kind of strong verifiability and privacy guarantees, because you want to run the computation as fast as possible, as fast as the hardware will let you. And when you do that, like you necessarily can't add integrity checking or privacy, because the only ways that we have to add integrity or privacy checking require taking additional steps in the computation. So it necessarily makes it slower. Like if you want to create a proof that you've done something correctly, you necessarily have to write some additional pieces of code that will then be run alongside your computation. So they immediately moves you away from the highest performance thing. Adding any kind of integrity like slows down performance. And then if you want privacy, that also adds computational cost, because you now need to add encryption on top of the computation. And there's all kinds of protocols for doing this. Things like MPC, some fractions of ZK, and FHE. And each of these gives you a very different blow up in the performance cost of running these algorithms and in these kinds of encryptions. And so that kind of like gives you this trade-off between performance, verifiability, and privacy. And the blockchain community kind of was primarily interested in establishing decentralized computation that you could trust. And so it kind of ratcheted the scale all the way to integrity and so to kind of verifiability. And that's why most of the applications of zero knowledge proofs have been in achieving verifiability. So, you trade off performance for achieving strong verifiability on like, no double spending and that kind of stuff. But privacy is quite difficult to do with zero knowledge proofs. And there's all kinds of like very specialized structures that can give you certain types of guarantees on certain types of programs. But the kind of conventional wisdom in the research community is that if you really want to be able to encrypt all computation, like everything about some large scale set of computation that you might do, and encrypt it fully so that nobody, like the computer that's running it or the people that run the computer or like the network, like nobody can tell what this computation is actually doing. You just have to go into FHE, like full homomorphic encryption is the only branch of the cryptography technology stack that can let you ratchet it all the privacy all the way. Now, but that comes with a huge kind of performance cost, but it makes sense for a range of computations.
Why is it that you think that the crypto community for the past decade is optimized for verifiability and performance over privacy? It feels like a contradiction to the kind of original Cypherpunk manifesto ethos.
Yeah. Well, I don't think it's a contradiction. I think they're both there. It's just that that's kind of where the focus was. So the Cypherpunk ethos was like, you want to be able to have decentralized networks that can coordinate, and ideally you want to do it privately. And so there's a whole bunch of stuff in the manifesto about privacy, but crucially, you need to be able to do this coordination. And Bitcoin, like the main problem that Bitcoin was trying to solve, which was probably the most successful of the original Cypherpunk products, it just kind of achieved this solution to the double spend problem in a scalable way that a lot of people could kind of use. And so it enabled decentralized money by solving this double spend problem. And the verifiability was the key component. And privacy was talked about, and the Bitcoiners, including Satoshi, wanted privacy, but they couldn't figure out how to really do it. And in fact, there's discussions about, like, I think in the old mailing list about using zero knowledge to try and bring privacy to Bitcoin. And so because they managed to have the system and it worked and it scaled, it just sort of took the entire cryptocurrency community down the path of like, how do you run other kinds of transactions and other kinds of contracts on top of this really cool blockchain primitive? And hey, you have this like really neat property that everyone can see the programs and you can see what people are doing. It's kind of like view source on the web. That level of, transparency in a sense led to a bunch of explosion of potential applications. And so the fact that all of it was in the public and in the clear kind of enabled the explosion. And at the same time, as people were thinking about making better and better blockchains, like getting rid of this like 10-minute block time nonsense and getting full programmability that like led to Ethereum, that was entirely about like, how do you make a better kind of computational infrastructure, not really addressing the privacy question. And it's only like in retrospect, after like 10 years of like now building this huge financial system, then people are like, wait, hold on. Like none of this is private. Like everyone can look at everything. Wait a minute. And that will cause like a whole range of problems unless we now come in and bring privacy into the equation. And so I think like it just sort of happened this way just because the integrity was more important at the time, to the set of people. But now it's like really time to encrypt everything.
Great. Well, that brings us to FHE. You mentioned earlier that kind of the cryptography research community has been pushing this as kind of a holy grail solution for privacy on blockchain.
And for all applications, like really, like I really do think that we'll see, like eventually we'll have email services and text messaging services and so on that all run on FHE because the world would just demand it. Like as soon as the computational cost gets low enough, which it should be fairly soon, it'll be straightforward for people to demand services that do this. And I predict that eventually governments will mandate it. So governments like the EU will point out that, hey, now that the technology is capable of doing this, there's no reason a centralized company should have access to your text messages and to your email. Right. And then they might, pass a law requiring something like FHE. Although I guess the chat control thing in Europe is like a,
that's a whole separate debate.
Yeah, it's a whole separate thing. But there's a very strong privacy-oriented community in the EU that could be pushing for this. So yeah, anyway, like this kind of decentralized computation triangle showed me that there were all these different technologies that are in different parts of the spectrum of performance, verifiability, and privacy, and that each of them was going to lead to different kinds of applications and different those trade-offs lead to different applications in different communities and so on.
Yeah.
And so I don't know, like 5 years ago, I sort of predicted that we'll see different companies and different communities pursue those different applications and those different use cases with these different technologies. And so there would be like a very successful set of computation networks around ZK, a bunch of successful computational networks around MPC and FHE. And ZK was just kind of like the first one that got off the ground. And I had the fortune of getting to know Ellie Bensasan and others very early. And like, we used to host a range of cryptographer research dinners and so on around conferences. And so we got to see the beginning of Starkware and the ZK push, and Falcon was using ZK at the time. It was for a while, Falcon and Zcash were the only groups pushing zero knowledge proofs.
Yep.
Give a bunch of grants to groups to develop the tech. And so we saw, and we could invest in companies that were pursuing that particular branch of technology, and enabled us to kind of be very early to this entire field that, 3 to 5 years later became massive.
Well, that's actually what I want to ask you is,
Yeah.
without shilling Zama too hard.
Yeah.
We know that you're an investor in Zama, but I have a clear understanding of how you got to this thesis. But what was your thesis?
Yeah, exactly. So after seeing ZK grow in this way, and because I knew that FHE was going to be needed, because of my understanding of this triangle, I knew that FHE was going to be needed to do the full encryption of things. I was already predicting that there would be a single team and company that would be developing the FHE technology in the same way that Starkware did it for ZK. And so I was at the time thinking, okay, is anyone doing this? Like, should we start a group to do this? And that's when I found Zama, and I was like, oh, great. Like, the team already exists. That's been doing this for a while. Fantastic team. And so then they made like a very obvious kind of fit to the thesis, right? And so,
Yeah.
and this kind of thinking is like, you have to be willing to be patient and on this kind of stuff, because this is like 5 years ahead of where other people are.
Yeah.
And you just have to, which is kind of, I don't know, the best time to invest in crypto and in technology in general. You want to be thinking about what is 5, 10, 15 years ahead,
Right.
and be placing like the right bets at the right time.
Did you at the time view Zama as kind of like a privacy maxi play, or did you think, okay, 5 years from now, there's going to be a wave of institutional adoption, and this is going to be the main driver for like privacy taking over?
Kind of neither. So I saw it much more as encryption is fundamental to computing at scale. If we are going to have any kind of strong guarantees from centralized parties about the privacy of our computation, or any strong guarantees from decentralized computation networks, we're absolutely going to have to use fully homomorphic encryption to develop these technologies. And therefore, a group that can figure it out and like do it well and like provide it as a really high quality set of libraries needs to exist to then provide the like scientific results, the technological innovations, the software libraries, the products, the services to both the centralized cloud and the decentralized systems. And it just so happened that like at the time, so it was kind of this curious thing where like I when I got to know Zama, it was primarily focused on the more centralized business landscape. Rand was already kind of interested in crypto and like active in crypto, but like, our discussions very early on, I was like, Rand, like focus on the crypto market, because, sure, the FHE is expensive, but like over here, we're paying $60 to add 2 numbers. Like, this is like, if you want to sell expensive compute, this is like the best market to do it in. And so I kind of like, Rand was already thinking this way, but like I was like already had independently come to the same conclusion.
Sure.
And so, we were able to bond over a shared understanding that like the crypto market is the place where that would need private computation for financial transactions way earlier than the centralized world. And so it made much more sense to deploy FHE in the crypto world and advance privacy and full encryption all the way. And then later, once the centralized players realize that they're like not really competitive with the better guarantees of this world, then they'll come along, right? And so
Interesting.
yeah, but I do think that, for example, like the use cases that I'm most interested in, so there's a range of use cases around financial transactions that I think are going to be really big. So everything from encrypted money to encrypted corporate records, like tokenizing stock, tokenizing all kinds of assets, having like strong guarantees about the privacy of various capital structures, also the privacy in governance structures. So those are like the early days. We're going to have like entire corporate structures on chain. We're going to have government systems on chain. I'm really excited about voting systems that preserve privacy and give you verifiability with identity. So you can use that as a thing in like, global, national referendums and things like that. And so I think all of those applications will happen out of the crypto industry. And then later we'll get to being able to have FHE based routing for text messages and email. So like I personally think it's insane that today we have such brittle communications infrastructure where, like we saw this massive Cloudflare outage yesterday. Signal, I think it's in AWS, but like it has like one provider, and if that one provider goes down, like all of Signal shuts down. This is not how humanity should be running its communications infrastructure.
Yeah.
We need to be doing this in large scale, robust, decentralized networks. And the only way to do that kind of communications infrastructure in a decentralized setting is with strong cryptographic privacy guarantees,
Yep.
which only FHE can give you. So from my perspective, it's like this kind of inevitability that like 5, 10, 15 years out, so much of this computation is happening in FHE. It's just kind of like a matter of like developing the tech, developing the hardware, and getting the adoption.
Well, I want to talk about one use case in particular. It should be noted that we're having this conversation in Buenos Aires, in Latin America, where consumer crypto adoption is enormous,
Massive.
by comparison to the rest of the world. Payments and banking on chain seem like an early wedge into consumer crypto adoption. We've got Raycash here today, who's building a self-custodial bank on chain using confidential stablecoins powered by FHE. How important is privacy and confidentiality for broad consumer adoption, not only in Latin America, but for the rest of the world?
Look, I think it's essential. The fact that we're running this financial system entirely in the clear is super dangerous. The reason it hasn't led to more problems is that the crypto industry is still like fairly small, but we're starting to see the beginnings of that. Like the kidnapping of the Ledger founders is an example. There's all kinds of stories of people around crypto conferences in some countries that are like less safe, that lead to various crypto people being targeted and whatnot. And the fact that we just have to face the reality that the world doesn't have perfect law enforcement, and also the reality that sometimes the law enforcement is in a government that is like opposing what is right to do. Unfortunately, you just can't rely on law enforcement actually being correct. It's sad that in 2025 that is still the case. There are many countries where, like the Wences Cáceres, who is I think an Argentinian who was very early into Bitcoin and really kind of liked this tech, and then was also really early into Zcash. Had a strong argument about this. Maybe it wasn't Wences, maybe it was somebody else. There's one kind of like early Bitcoiner from Argentina that points out that like having the ability of having privacy is fundamental in most of the world, because there are a few jurisdictions that have very strong rule of law, but most of them have kind of like this more probabilistic rule of law where all kinds of bad actors get into the system and then leak information and then target people. And so you can be like, you just don't have strong safety and security for people globally if all of your digital computation, including your text messages, your email, your financial transactions, are publicly available for everyone to read. Like, that's just not a good system to have. And so privacy is an absolute requirement. And the only way to deliver privacy at scale for arbitrary computation, from my perspective, is FHE. I think there are some specialized cases where ZK can be used. But in practice, the like to be able to do everything you want, like FHE is just a better approach.
Okay, so speaking of Zcash, I'd be remiss if we didn't talk about the current privacy meta.
Yeah.
I want to get your high-level take on this. Do you think this is an orchestrated takeover by like a crypto cabal that's driving this activity on Twitter, or has the origin window shifted from your perspective?
So I don't know. My perspective is that Zcash has been tragically undervalued for a long time. That's just kind of like public markets. There's this idea in economics that markets are supposed to be efficient and correct and rational. And I completely disagree with it. I think it's 100% wrong. Markets are not actually very rational, and they're not actually correct. And you can see that by just looking at where does the capital go quarter over quarter in Wall Street, and zoom out and think about what's going to matter 10 to 20 years out, like totally irrational capital expenditures all over the place. So I've just gotten used to the fact that in public markets, you'll have these things that are dramatically undervalued because the world doesn't understand reality. Think about Tesla being super undervalued for years, like with these like insane shorts. And then look at it now, right? Like the market eventually sort of caught up. And I think it's still like they're massively underpricing the build out of robotics. Like they have, like, even though Elon has been saying this for like years now, the market hasn't understood what is going to happen when you have humanoid robots being able to run production in an automated way. Like there's no model that I've seen from any financial analyst anywhere that remotely comes close to correctly valuing Tesla on that one claim. And so that just should give you an example that, like, if that's the case in like the most sophisticated market, in the crypto market, which is not the most sophisticated, the thinking is just way backward. So it is totally possible for super valuable technologies to be dramatically undervalued. And so my perspective is Zcash was super tragically undervalued for a while. Now, what's happening now is a hard question. Like, it's not clear whether the market is now understanding this better and now repricing Zcash. That's, I think, one component of what's going on. There's definitely a lot of shilling going on, and like, sure, in the crypto world that helps. But I think that there's also like the effect of near intents. So one of the problems for Zcash was that because it wasn't well connected to the rest of the crypto markets, money that might be wanting to go into Zcash couldn't get there from various other contracts. And the moment that near intents enabled that trading, a bunch of money was able to flow into Zcash. And then there's also the connection with Bitcoin. So I forgot what the name of this piece of technology is, but the Zcash community built a connector to Bitcoin. And so a lot of Bitcoin that wanted to move into Zcash now was able to do it. Because you have to like remember that the transactional flow and history is all traceable by everybody. So moves may not actually be able to happen over the system until they're directly connected in a kind of decentralized bridge of some sort. And so as that connectivity becomes better, you'll see some kind of capital move. So I think another component is a lot of money was trying to move into Zcash, but just couldn't, and eventually was able to do it. One example of this money that I think will eventually end up in Zcash, Monero, and others is like there's this set of coins in Bitcoin that are quantum vulnerable, where once we have quantum computers, all of Satoshi's coins, or not all, but like a chunk of Satoshi's coins and a set of others, it's something like 10 to 20% of I think it's like around 10%, 10 to 20% of the supply of Bitcoin is vulnerable to this quantum attack. And so as soon as people have a quantum computer that's able to steal those coins, what do you think is going to happen to those coins immediately? They're just going to go into a privacy coin of some sort. So there's like, and they're probably going to be distributed and spread over a bunch of them. And so like my prediction is that at some point, if Bitcoin doesn't fix this, they will see a bunch of those coins move into a privacy coin eventually. And so there's just a lot of pools of capital that want to move into Zcash and or similar privacy-oriented tech. They just currently can't. One other factor here, because we're talking about Argentina, Argentina had like massive inflation for a long time. Like we're talking about, you know, the US and the EU freaked out over 15% inflation a few years ago. Like everyone was, you know, like, this is insane. Argentina had 100 to 150% inflation per year. It's like 10x more. It hit 250% per year at the kind of peak at the very last moment. And so in that kind of environment, like you can't save. Like there's no idea of like saving for college or saving for a house or whatever. Like money's gonna like be worthless by the end of the week, or not fully worthless, but like it's gonna drop by, you know, double-digit percents like week over time. And so you just like cannot possibly, you know, save in any way. And so when you have an economy like that, what do people do with the cash they get? Immediately move it into other assets, immediately move it into dollars or other things. And so this is why the adoption of crypto in Argentina is enormous. It's people moved from the peso into digital dollars and other things like that, like, you know, USDC and USDT and whatnot. And so when you have, but by the way, all of that is in the clear right now. So, and it's all traceable. And so, you know, you can start arguing about like whether that was okay or not to do. Like technically under the last administration, that was not okay to do, to like go through these like black market ways of getting stable coins. On the flip side, from like a humanitarian perspective, this is like a humanitarian crisis that like the government is like mismanaging the economy to this degree. So like you can't at all fault the people for doing this. Especially because now the government today is like allows and enables this kind of transaction. So like you will have this happening across many countries in the world where there are severe capital controls, severe inflation, just severe economic mismanagement. You'll see large amounts of capital moving into technologies that can enable a better rule set. I think that all of this needs to be like structured and codified with actual legal jurisdictions in the internet. Like I think digital jurisdictions and things like the network state movement and so on are really powerful and a good way of kind of structuring this in a way that like is legible to courts of law and all of that kind of stuff. And so I think that's going to come eventually. But in the meantime, just think of, China, for example. A huge amount of the money in crypto is from China. And all of that is like pseudo reported in China or not, or in Hong Kong. And all of that is moving between like these, capital pools. And they're usually structured in other countries, right? It's like kind of like some assets in Singapore and some other places, and all of it is moving through these systems, right? And so there's a massive economy globally that is kind of fragmented into all of these like jurisdictions, but there's kind of asset flows that are kind of escaping badly managed economies and going to better managed economies, which by the way, I think is like if the US can play its cards right with stablecoins, it could really extend the longevity of the dollar massively by becoming like, by retaining the global reserve currency status, by being like the dominant de facto like reference currency to use for all of the crypto assets.
Yeah. I want to talk about network states and sovereignty in a second, but back to your point about markets being irrational, what is the biggest thing that people are getting wrong about privacy?
I mean, probably the biggest thing is like not like dramatically under investing in it. Like we should be having dramatically better technology, services, applications. Like, to me, it's insane that so many wallets are still doing everything in the clear. And so I think like and so many smart contracts should be operating in fully privacy modes. And so I really think that the blockchains of 5-10 years from now and the activity across most assets will be encrypted in a structure that is compliant, meaning you need to have a structure that is compatible with local laws. Like I'm not like a ultra like anarchist who is like like some of the cypherpunks where like these very strong anarchists that are like anti-government. I'm not that. I very much I'm like in the opposite side, maybe not the opposite, but in the middle somewhere of saying many governments are extremely good and have been forces of extreme good globally. And you need to enable good rule of law and good courts and good ways of mediating and adjudicating disputes. And you need to establish rule frameworks that are going to be followed by a society. Now, you need the ability to exit. Like you need the ability to say, hey, if I don't want to participate in these legal structures, I need to be able to go somewhere else. Balaji talks about this quite a bit, having the ability to exit, which is not clear everywhere, right? Like there's examples like North Korea, which are extreme, but there's a lot of other countries that really don't want you to leave, and they make it extremely difficult for their citizens to go, even though they mismanage their environment. So sorry, what was going with this? Yeah. So what people get wrong about privacy, like we just need to have kind of infrastructure that is compatible with the legal frameworks of the world, but that really encrypts everything so that only the people and the groups that have been authorized to view the results can do so. I think Zcash was an early pioneer here on doing like the selective disclosure structure for your own transactions that fits the legal structures of a lot of the countries in the world, and it inhibits the mass surveillance that Snowden pointed out. Like Snowden pointed out this like really terrible mass surveillance that was happening. And so the Zcash structure kind of walks the balance between giving kind of this like warrant-oriented look into your personal effects and your personal transactions that you can choose to give, or you can be compelled to give, but it does not make it clear to like all states, all corporations, and all people in the world to make you subject to attack, right? And so I think like eventually all large value transactions in or like the high volume of transactions on blockchains will be happening over fully private settings.
So I want to close this out on the network state concept. You've done a lot of funding for public goods. You support a lot of research in the space. You're involved in I can't recall the name of the initiative through Crecimiento to build an economic zone here. You can touch on that a little bit, but you've done some really interesting thinking on this. We talked about it not too long ago about the idea of kind of like leapfrogging the economy as a result of implementing blockchain technology. Can you tell me a little bit about the analogy? You mentioned something about kind of India implementing going directly to mobile first was like an interesting comparison and something that, you know, here in Argentina you might be able to do through blockchain.
Yeah. So because of the inflation, Argentina kind of onboarded millions of people into crypto really quickly, right? So we have, I think, 4 to 8 million people, I think like around 8 million people in Argentina that use stablecoins in some way. And so a lot of people are already kind of some degree of crypto native. And they're really seeking these tools and systems because they're like escaping badly run economic structures. And at the same time, the crypto industry for the last 15 years has been building all the tools and building blocks that you can use to build a modern 21st century economy. And so it would be great to be able to pull together, you know, the ability to run a basic currency, the ability to have a property registry, a corporate registry, the ability to like instantiate those corporations, trade those property assets, be able to get credit with those assets, to be able to get loans, to get a mortgage, like all of these like basic, you know, maybe saving products like payday loans. Like you think of the top 20 basic economic transactions that most people do, and instead of using the, you know, 19th, 20th century ancient technology, build 21st century technology on top of crypto that would be immediately accessible to global capital markets and immediately accessible to AI, and like build like an economic infrastructure on chain for the 21st century. And so like you could do this in a place like Argentina and completely leapfrog the rest of the economies in the world. And so my claim here is if Argentina could set up a 21st century digital infrastructure, the digital economic infrastructure, it could leapfrog a ton of other countries and jump from its current standing in like, you know, numbers around the 60th or 70th country by GDP up to like one of the top 20 countries, like very quickly. I think this could happen quite fast if we could implement that kind of better kind of economic infrastructure. And a way to do it is you like think about those frictions, think about building the companies that provide that service. You could, the idea of like an economic zone came from looking at places like Singapore and South Korea and Dubai, where better economic structures were built to enable this kind of like fast economic transformation. And Dubai in particular has like 50 or so different economic zones. They're all related to specific locations. But the idea that we came up with was, what if instead of it being related to a location, it's just related to a specific digital envelope? Like you should be able to draw a border around some amount of digital activity. And that's where a blockchain just fits perfectly. You can say, here's a blockchain. This blockchain is where the digital economic zone is. All transactions that happen here are under that jurisdiction only. And then you can trade internationally from this jurisdiction to some other jurisdiction by having a bridge transaction or, you know, moving some assets or whatever. And so that enables you to create like a different economic zone, different rule sets, and then try out like the sandbox of, you know, possibilities entirely on a blockchain and so on. So like that's the current plan and hope, and like it's like super exciting. It's like, you know, at the edge of like political economic theory and practice and kind of like business building and so on.
Yeah, that's amazing. And presumably, if this works out, you're doing, you know, census data, voting, land registries, mortgages, payroll on chain. There's going to be a big privacy component.
Yeah, everything we've been talking about for 10, 15 years can now finally happen because privacy is appearing, right? Like the big blocker for land registries, corporate registries, and so on was privacy. Like there's no way you can convince a corporation to put its stock ledger on a blockchain if you don't have the basic requirement of privacy. Same thing for property. Like you need, like there's some amount of information that needs to be public, but a lot of the information has to be private. And because blockchains are fully public, you can't do that. And so now with privacy, like as FHE comes in, we will be able to do those kinds of things. Yeah. And so I think it's going to be super interesting next 3 to 5 years as all of these applications come online.
Amazing. Well, thank you so much for your time. I think it's an optimistic note to end on. Thank you, Juan, for joining us.
Thank you so much. Cheers.